नमस्कार विद्यार्थी मित्रांनो. In the last lecture we have studied the definition of scalar product and we have started solving examples on it. So this is the first example. Already we have discussed this in last lecture. I will repeat it. Find a bar dot b bar. If magnitude of a bar is 3, magnitude of b bar is root 6, the angle between a bar and b bar is 45 degree. So this much information is given. We have definition for a bar dot b bar as magnitude of a bar into magnitude of b bar into cos theta. So we substitute these values. Magnitude of a bar is 3, magnitude of b bar is root 6, and angle theta is 45 degree. We write the value of cos 45 degree and simplify this and get the answer. So this 3 root 3 is the value of a bar dot b bar. So this was first example. Now let us discuss second example. If a bar is equal to 3i plus 4j minus 5k, b bar is equal to 3i minus 4j minus 5k, find dot product a bar dot b bar, angle between a bar and b bar, scalar projection of a bar in the direction of b bar, the vector projection of b bar along a bar. Now this year this question will not be asked in the exam because the vector projection, vector product, these two concepts are deleted. Vector product, no, 1 minute, sorry. Vector projection is not deleted, vector triple product is deleted. So this question is for exam purpose. Now if we observe the difference between example 1 and example 2, in example 1 for finding a bar dot b bar, this angle was given, and in second example angle is not given. Without knowing angle we have to find a bar dot b bar. Actually we are asked to find angle between a bar and b bar. So if we want to use definition, first basic definition, that is ab cos theta, then we have limitations here. We do not know value of theta, so we cannot use that. Then how to find a bar dot b bar? We use Cartesian form. What is that Cartesian form? The scalar product of vectors a bar and b bar is a1 b1 plus a2 b2 plus a3 b3. So here a1, this is a2 and this is a3. Here is b1, b2 and b3. So a1 a2, 3 into 3, b1 a2 b2, 4 into minus 4, and a3 b3. Means we have to take the product of corresponding components and add them. Simplification gives me answer 18. So value of a bar dot b bar is 18. Now magnitude of a bar, which is root 9, this 3 square 9, 4 square 16, and minus 5 square is 25. So this is magnitude of a bar. For magnitude of b bar, we look at vector b, 3 square 9, minus 4 square 16, 5 square is 25. So again it is root 50. The angle between a bar and b bar is given by formula cos theta is equal to a bar dot b bar upon product of their magnitudes. A bar dot b bar, it is 18. So we take this 18 here. Magnitude of a bar root 50. Magnitude of b bar root 50. Their product is 50. We simplify this and we get value of theta as cos in, this is cos theta. So theta is equal to cos inverse 18 upon 50. You may write it as cos inverse 9 upon 25 also. 2 is common. The scalar projection of A bar in the direction of B bar. The scalar projection of A bar in the direction of B bar is given by formula A bar dot B bar upon magnitude of B bar. A bar dot B bar is 18. Magnitude of B bar is root 50. So root 50 can be written as 25 into 2. Square root of 25 is 5. So this is the scalar projection of vector A bar on vector B bar. Now what is vector projection of B bar along A bar? The vector projection of B bar along A bar is A bar dot B bar upon magnitude of A bar into A cap. I have simplified it and written it in this form. We know all these things. We know value of A bar dot B bar, which is 18 upon 18. Okay. Magnitude of B bars, A bar square, it is 50. And A bar and vector A bar. This vector A bar taken as it is. Just do little simplification, that will give vector projection. We have this vector projection in syllabus this year also, but vector triple product, that article is deleted. Okay, so this was second example. Now let us move to third problem. Find the value of A. A is constant. Value of A for which vectors 3i plus 2j minus 9k and I plus aj plus 3k are perpendicular to each other, are parallel to each other. So first case we consider perpendicular. For two vectors to be perpendicular to each other, their dot product must be 0. This is necessary and sufficient condition for two vectors to be perpendicular to each other. So P bar dot Q bar. We write these two vectors here and use Cartesian form of scalar product to work out this product. 3 into 1, 2 into A and 9 into 3. So simplification will give you value of A. So if A is equal to minus 15, vectors are perpendicular to each other. If A is equal to minus 15, then vectors are perpendicular to each other. Now what is the condition? What is the value of A for which vectors will be parallel? So two vectors are parallel. Two vectors are parallel if one is a scalar multiple of other or their coefficients are in proportion. So this 3 to 9, 3 to 9, 1a3, 1a3, they are they should be in proportion. They should be in proportion. हे proportion मध्ये असावेत म्हणून अशा पद्धतीने आपण ते मांडलेले आहेत. And simplification gives me A is equal to 3 by 2. Okay. So this was one simple question about perpendicular and parallel. Then fourth question is, if A bar is equal to 1i plus 2j minus 3k, B bar is equal to 3i minus j plus 2k, find the angle between vectors 2a bar plus b bar and a bar plus 2b bar. आपल्याला a bar b bar हे दोन वेक्टर दिलेत आणि अँगल कोणामधला काढायचा आहे? हे दोन वेगळेच वेक्टर आहेत, त्यांच्यामधला अँगल काढायचा आहे. मग आपण त्यांना काहीतरी नाव देऊयात. पहिल्यांदा हे a bar b bar लिहून घेतले. We name this first vector a bar 2a bar plus b bar as m bar. I have worked out that vector here. Second vector a bar plus 2b bar, I have named it as m bar and I have added them, work out that vector n bar, m bar, and then take their dot product of m bar and n bar. So this m bar dot n bar, by using Cartesian form, this 5 into 7 3 into 0 and minus 4 into 1. That gives me 31. So m bar dot n bar is 31. Magnitude of m bar means magnitude of this vector. Magnitude of m bar means magnitude of this vector. 5 square plus 3 square plus minus 4 square under square root sign. And simplification gives root 50. This is magnitude of m bar. Magnitude of n bar. Here is vector n bar. And this is magnitude of the vector n bar. If theta is the angle between m bar and n bar, then cos theta is given by formula their dot product m bar dot n bar divided by product of their magnitudes. We have already obtained their dot product. Here it is 31 and product of their magnitudes. These are magnitudes. Their product is 50. So theta is equal to cos inverse 31 upon 50 is the angle between them. Them means 2a bar and a bar plus 2b bar ह्या दोन वेक्टर मधला तो अँगल आहे. पुढचा प्रश्न आहे, if a line makes angles 90 degree, 60 degree and 30 degree with the positive directions of x, y and z axis respectively, then find its direction cosines. Now let me revise this concept of direction cosines. Angle made by a line with coordinate axis are called direction angles. So direction angles of the line in this problem, which is called a line, direction cosines of this line are 90 degree, 60 degree and 30 degree. What are direction cosines? Direction cosines of the line are cosine ratios of these angles. So I have to just write value of cos 90 degree, cos 60 degree and cos 30 degree. Cos 90 is 0, cos 60 is 1 by root 2 and cos 30 is root 3 by 2. So these are direction cosines of the line. So this is one simple question. Such type of question may be asked for 1 mark or 2 mark in board exam. Okay. Now let us move to next 6th question. Find the vector projection of PQ bar on AB bar. आपल्याला एका वेक्टरचं दुसऱ्या वेक्टरवर प्रोजेक्शन काढायचे आहे. कोणतं प्रोजेक्शन? Vector projection. There are two types of projection, scalar projection and vector projection. Coordinates of point P, Q, A, B are given here. So we make use of these coordinates to write vector PQ bar and vector AB bar. So I have worked out these calculations. This is my PQ bar, this is my AB bar. We know vector projection of vector PQ bar on AB bar is given by formula dot product of those two vectors, here this dot product, divided by magnitude of square of the magnitude of second vector. So here I have taken square of magnitude of AB bar and it is to be multiplied by AB bar. If we want vector product, we have to multiply by this vector. If we don't want vector product, leave it as it is. So we substitute these values. This is PQ bar, this is AB bar, their dot product, then magnitude square of the magnitude of AB bar, 3 minus 2 6 त्यांचे स्क्वेअर केलेले आहेत and it is to be multiplied by AB bar. याला मल्टिप्लाय करायचं आहे AB बारने. खालच्या ओळीला मी AB बार लिहिलेला आहे, फक्त ह्या लाईनमध्ये AB बार लिहायचा राहिला होता, तो इथे लिहिला. This is AB bar. This is vector AB bar. So this is the vector projection of vector PQ bar on AB bar. Okay. So this was also simple, but it was based on formula. Next question is, find the value of lambda. Find the value of constant lambda for which the angle between vectors A bar and B bar is obtuse. We know how to find cosine ratio of angle between them. So if theta is the angle between these given vectors a bar and b bar, then cos theta is given by their dot product a bar dot b bar divided by product of their magnitudes. Now if theta is obtuse, then cos theta will be negative. Theta is obtuse means cos theta negative, and cos theta is negative means this expression must be negative. This expression is negative if dot product is negative, because magnitude is always non-negative. Now dot product means their scalar product we obtain by using scalar form of dot product. Here dot is required. We use a1 into b1, a2 into b2, a3 into b3 हा फॉर्म्युला वापरून डॉट प्रोडक्ट लिहिला तर डॉट प्रोडक्ट should be negative. So simplification shows me this 14 lambda square minus 7 lambda should be negative. Now take lambda common, further simplify it like this. Now for where should be lambda, what should be value of lambda, म्हणजे लॅम्बडाची किंमत कशी असायला पाहिजे. तर ही लॅम्बडाची किंमत आहे if lambda lies between 0 and 1 by 2. 0 and 1 by 2. Here I have used one technique. If we have expression x minus a into x minus b, and if we want this product to be negative, for what values of x this expression will be negative, then answer is if a is less than b, if a is smaller than b, then all numbers which lie between a and b, x lies between a and b. This is the result. Now here lambda can be read as lambda minus 0 into lambda minus half. So a is 0, b is half. If lambda lies between a and b means 0 and half, then definitely this product will be negative, and cos theta will be negative and theta will be obtuse. Okay, so for question is for what values of lambdas this angle will be obtuse. If lambda lies between 0 to half, then angle will between a bar and b bar will be obtuse angle. Next question is find the direction cosines of the vector 2i plus 2j minus k. Now we know if we have a vector, then components of that vector along I, j, k means coefficients of I, j, k, here 2, 2 minus 1, they are direction ratios. And we know how to find direction cosines from direction ratios. So let us find magnitude of vector a bar. Magnitude of vector a bar is 3. Divide this vector a bar by its own magnitude to find unit vector in that direction. So this vector a bar is divided by 3 and this vector is obtained. This is a cap. This is vector a cap. Vector a cap means unit vector in the direction of a bar. And coefficients of I, j, k in unit vector gives me the direction cosines. So these are direction cosines of this vector. Very simple problem. Now next one is find position of point P. Find the position vector of point P such that AB is inclined to x-axis at 45 degree, y-axis at 60 degree. Okay, only two angles are given. Vector AB bar makes angles 45 degree, 60 degree. Actually this should be OP, not AB. This should be OP, because nothing is said about A and B. So OP is inclined at 45 degree. Line OP is inclined at 45 degree with x-axis, 60 degree at y-axis, and length of segment OP is 12. Length of segment OP is 12. Then find the position vector of point P. P या पॉइंटचा पोझिशन वेक्टर आपल्याला काढायचा आहे. कसा काढायचा पाहूया. थोडासा टेक्निकल प्रॉब्लेम आहे, थोडासा डिफिकल्ट असा क्वेश्चन आहे. L means cos alpha. Alpha is 45 degree, so it is 1 by root 2. M is cos beta, means cos 60 degree, it is 1 by 2. N means cos gamma, angle gamma is not given. We have this relation L square plus M square plus N square is equal to 1. So sum of the squares of these three things is 1. This gives me cos square gamma is equal to 1 by 4. Means cos gamma is equal to plus or minus 1 by 2. Now R bar, which is equal to magnitude of R bar into R cap. Magnitude of R bar is given, which is 12, and into R cap, this is R cap, Li plus Mj plus Nk. Values of Lmn are in our hand. So there are two possible places for point P. So one position vector of point P is 6 root 2i plus 6j plus 6k, and second position vector is minus 6k. So once we take plus sign, once we take second time we take minus sign, and we get two possible positions for point P. Because there are two lines which makes angle 45 degree with x-axis and 60 degree with y-axis. Now next question. A line makes angles 45 degree, 60 degree with the positive directions of y and z axis respectively. Find the angle made by the line with positive direction of x-axis. So this question is very much similar to previous one. We have given values of beta and gamma. These are values of beta and gamma, and we are asked to find the value of alpha. हा अल्फा आपल्याला माहित नाही. Relation is cos square alpha plus cos square beta plus cos square gamma is equal to 1. We make use of values of beta and gamma. Write value of cos beta, cos gamma, and simplify them. This simplification shows me cos alpha is equal to plus or minus 1 by 2. So alpha must be 60 degree or 120 degree. That means there are two lines which satisfy the condition, and their direction angles are 45, 60, 60 or 45, 60, 120. Okay. Next one is a line passes through points. These 2 points are given. Find the direction ratios and direction cosines of the line so that angle alpha is acute. Alpha is angle between them. Line passes through these 2 points. What is alpha? Alpha is not given in mentioned in the problem. Okay. Alpha is not mentioned in the problem. Yes. Line passes through these 2 points. Find direction ratios and direction cosines of line so that angle alpha is acute. Okay. AB is directed so that angle alpha. Yes. Now this this line AB has 2 directions. Line AB, when we say line AB, it has 2 directions. One is directed from A towards B, and another direction is directed from B towards A. So in one of the directions, this angle alpha is acute, and in another direction alpha is obtuse. Okay, so let us first read the solution, then I will explain this thing in detail, how this angle alpha is, how to make use of this fact that alpha is acute. So from coordinates of A and B, we write A bar and B bar. And after writing A bar and B bar, we write vector AB bar. This is vector AB bar. And we observe that coefficients of I, J, K, that is minus 4, 4, 2, they are direction ratios of line AB. Direction ratios are not unique. If we multiply them by any constant, they are also direction ratios. So minus 4k, 4k, 2k, they are direction ratios of line AB. Now we find value of k. Find value of k. Now how to find value of k? How to find value of k? If they are direction cosines, then sum of their squares must be 1. So using that property L square plus M square plus N square is equal to 1, we get this k, put that value of k here, and for cos alpha is equal to minus 4k, k should be minus 1 by 6. For cos alpha to be positive, this minus sign is already there. So what should be, how should this k be? K should be negative. Then only this product will be positive. So for this product to be positive, k has to be negative, and k has two possible values. So we choose k is equal to minus 1 by 6. And by taking k is equal to minus 1 by 6, we simplify that minus 4k, 4k and 2k and write the direction cosines of line AB. Okay. So this was about the problems which are based on scalar product. In the next lecture we will solve some problems from geometry which are based on scalar product. तर आजचं लेक्चर आपण इथं थांबूया. धन्यवाद.